Hello again, it's Coop with Lennox Learning Solutions, and today we're going to tackle another one of the questions that we've had coming in, and that question is, how do you properly check the static pressure on a system, and what good does that do you? So static pressure obviously is the pressure exerted on the ductwork throughout the system, and it is necessary to understand the parameters of that static pressure to be able to alleviate all kinds of issues. When you come to a system for a no-cool situation, it's pretty common for the technician to want to go out to the compressor and say, hey, yep, the compressor is overheated, and that's because the evaporator coil is dirty, so you just need to clean your evaporator coil, or maybe to the extreme of you need to replace your compressor because that's what's going on. Then you find yourself later on down the road putting in a compressor and you're still having the exact same issue again. Could be static pressure or airflow through that system is the main culprit, and a lot of times air pressure or airflow through the system becomes more of a problem overall than not. So it's really important to understand the basics of checking static pressure, and that's what we're going to cover today. Let's get started. Today we're going to be using our manometer paired with our static pressure probes. So there are lots of different types, makes, and models of static pressure probes. I really enjoy these simply for the fact that they are magnetic and will hold themselves in place, so you don't have to stand on the side of the unit making sure that they're staying in place. The next thing that's really important when you're talking about the placement of these probes is making sure that you're keeping it inside the box. Again, that's something that is going to be paramount in determining that you have the right static pressure for the system. A lot of technicians will want to install these to where they're one's on the opposite side of the evaporator coil and one's on the other side of the air filter. That's not the proper way to check static pressure. You want to keep it inside the box. So let's start with our first probe here. We're going to reach around the furnace and insert it. As you can see, this is the evaporator coil. We're going to insert it in a hole that's still within the furnace. That's static probe number one. Our second one is going to be on the other side of the heat exchanger, but still inside this box. Remember, keep it inside the box. So for this one, it's going right next to the blower motor, and they're both in place. The reason that that is so important is because all of these, the evaporator coil and the filter are going to affect that static pressure. And if you're on the other side of it, you're not getting a proper reading. So let's make sure that, like I said, you keep it inside the box. Now for an air handler, your evaporator coil is a part of that box, so it's important to make sure that it's before the filter, and then after or by that blower motor. So making sure again that it stays inside that box. Don't go outside of that furnace cavity. Don't go outside of that air handler cavity. So from this point, we're going to turn the system on. We've got our manometer on already. Let's see what she has. Right now, the static pressure of this system, which for our purposes, we're in a lab here and don't have a lot of duct work running to the system, so and it deadheads right above the unit, so it's going to be a little bit off. But for this particular system, and it's not outside of the realm of normal, this particular system is running at a 0.17, 0.16, kind of teetering back and forth between those inches of water column. You can always find on the equipment from the data plate down here at the bottom, it's going to tell you what the maximum static pressure is for that system. For this particular system, I've taken the liberty of going ahead and checking that out. For this particular system, it is 0.5 inches of water column. So if this number on our manometer were above 0.5 inches of water column, we know that we have an airflow issue. So as you're looking at the system, make sure as it's running, while the equipment is at full bore, that you're not going above that 0.5. And if you start inching closer and closer to that, you're going to want to start the process of finding out, okay, what's in the way? Could it be that I have a filthy dirty evaporator coil? Yes, that could be a problem. Could it be that I have a really dirty filter? Yes, that could be a problem. There are lots of different pieces of this puzzle that can cause static pressure to go way out of whack. So making sure that you know how to check static pressure to verify that it's within that range is very, very important. This is something that when you're doing a maintenance or a service visit, it's very important to be able to explain to a customer, hey, this is what's going on with your system, and this is why I don't believe that your compressor is what's the problem is, or this is why I don't believe that the equipment is low on refrigerant. There are lots of other pieces of the puzzle. Most often you're going to find that airflow is a major issue within the HVAC system. Again, thank you. This is all we have for today. We'll see you next time.